Meaning, sir.
Yes. Lagrange's method. Okay. The Lagrange's method is a method which is used to solve the linear first order partial differential equation. The differential equation is in the form, the PDE is of the form, PP plus QQ is equal to R, where capital P, capital Q, capital R are constants or functions of x, y, z, or functions of x, y, z, and small p is equal to dou z by dou x, and small q is equal to dou z by dou y. This is the first order linear partial differential equation. To solve this type of equations, we have to take the auxiliary equations called Lagrange's auxiliary equations. Lagrange's auxiliary equations. The Lagrange's auxiliary equations are dx by p is equal to dy by q is equal to dz by r. P is the coefficient of small p, q is the coefficient of small q, and r is the right side term. Now, this is a simultaneous total differential equation. This system has an infinitely many solutions. Among all those solutions, we need to find at least two solutions called u of x, y, z is equal to C1 and v of x, y, z is equal to C2. Now, these are the two solutions of the corresponding auxiliary equations dx by p equal to dy by q is equal to dz by r, and these are the solutions for the given partial differential equation pp plus qq is equal to r. So, the general solution is in the form, therefore the general solution is of the form, either f of u comma v is equal to 0 or u is equal to f of v or v is equal to f of u, either in the form of f of uv is equal to 0 or u is equal to f of v or v equal to f of u, where capital F is an arbitrary function. Okay. Now, same question, sorry, PL Polytechnic Lecturers lo different thing adigadandi. The general solution of this is from PL Polytechnic Lecturers. The general solution of the linear PDE, PP plus QQ is equal to R is. Just we are given options. First option is phi of u comma v is equal to 1. Second option, phi of u comma v is equal to -1. And third option, phi of u comma v is equal to 0. And fourth option, none of these. These are the options. As we know that the general solution of the PP plus QQ is equal to f of u comma v equal to 0 or u equal to f of v or v equal to f of u. Where f is not fixed, it is an arbitrary constant. In place of f, we can take pi also. So general solution is pi of u comma v is equal to 0. Okay. Now, I am taking another question from JL. If P equal to is from JL. Sorry. If P is equal to dou z by dou x, Q small q is equal to dou z by dou y. Then 1 second. No problem. Then the auxiliary equations of the PDE partial differential equation PP plus QQ is equal to R. Okay. Now we know that the Lagrange's auxiliary equations are simply auxiliary equations, or Lagrange's auxiliary equations are dx by p is equal to dy by q is equal to dz by r. Okay, simply this is the direct question of the GS. Now I am taking another question from JL. The Lagrange's is also from JL. The Lagrange's auxiliary equations for y square p minus, I am writing in the next line, that is y square p minus xyq is equal to x into z minus 2y. Okay. This is the given PDE. Now we have to compare the given PDE with PP plus QQ is equal to R. So here P, capital P is equal to y square, small p coefficient, capital Q is equal to small q coefficient minus xy, and R is equal to right side term x into z minus 2y. So Lagrange's auxiliary equations are Lagrange's auxiliary equations are, we have formula dx by p is equal to dy by q is equal to, I am writing one time, dx by p is equal to dy by q is equal to dz by r. That means dx by y square is equal to dy by minus xy is equal to dz by x into z minus 2y. We are comparing the given partial differential equation with PP plus QQ is equal to R, and the corresponding auxiliary equations are dx by p is equal to dy by q is equal to dz by r. Okay. Now I am taking one question from DL. The solution of the PDE. The solution of the
sir. Good
yes.
Hello.
Yes.
Good evening, sir.
Good evening, ma'am.
Sir, this dy by dx by y square is equals to dy by minus xy. We will leave it like that only, sir. We will not further solve it.
No need to. It is just asking auxiliary equations, not the solution. Okay, they are asking only Lagrange's auxiliary equations, not the general solution of the given partial differential equation. Okay. Now I am taking another problem. The solution of the partial differential equation xp plus yq is equal to z is. This is the given partial differential equation. We have to compare the given equation with the pp plus qq is equal to. So p is equal to x, q is equal to y, r is equal to outside term. Therefore, the auxiliary equations are dx by p, that is x is equal to dy by that is y is equal to dz by r. Okay. Now we can solve this system of
Excuse
equations.
me, sir. dz by z kada.
Yes, this is z. In place of r, I am writing z. Okay. Now this system of equations can be solved by using either the method of grouping or the method of multipliers. So first I am consider dx by p, dx by x is equal to dy by y. Okay, this is called method of grouping. While consider dx dy terms, it contains only x y terms. If it is contains z term also, we can eliminate z from these two from this equation. Okay. Now direct here it is in the form of variable separable. So by integration we will get log x is equal to log y plus arbitrary constant is log c1, that is log x is equal to log c1 y. So x is equal to c1 y, that is x by y is equal to c1. This is the first curve, that is u of x y z equal to c1 form. Here z is missing, and I am consider either we can consider dx by dy, dx by dz or dy by dz. Because it contains an infinitely many solutions, we have to pick up at least two solutions. For this, I am consider dy by y is equal to dz by z. Okay, you may consider dx by x equal to dz by z also. Okay, by integration, we'll get log y is equal to log z plus arbitrary constant c2, that is y is equal to c2z, that is y by z is equal to c2. These are the two solutions. Okay, two solutions. This system contains infinitely many solutions. We are finding two solutions. Okay, therefore the general solution is the general solution is some function, either f or phi, whatever the function, x by y comma y by z is equal to 0. This is the general solution of the given partial differential equation. Okay. Now I am taking another problem from DL. It is also from DL. Yeah. The general solution of of the partial differential equation PDE xp plus yq is equal to x is. So I'm comparing the given equation with the pp plus qq is equal to r. So p is equal to capital P is equal to x, q is equal to y, and r is equal to x. So the corresponding Lagrange's auxiliary equations are dx by p, x, dy by q, y, dz by r, that is x. Okay. Now we can solve the system of equations either considering whatever the values we can consider. I am taking for my convenience, I am considering dx by x is equal to dz by dx. You may consider other terms also. Here x will be cancelled. So by integration, we get x is equal to z plus c1. That is x minus z is equal to c1 is the first general solution. Now I am consider another curve that is dy by y is equal to dz by x consider చేయడానికి లేదండి, ఎందుకంటే ఇందులో x ఉంది, దీన్ని ఎలిమినేట్ చేయాలంటే మళ్ళీ ఇంకా ప్రొసీజర్ అవుతుంది. దట్స్ వై ఐ am considering dx by x is equal to dy by y. So by integration we'll get log x is equal to log y plus arbitrary constant log c2. That is x is equal to c2y. That is x by y is equal to c2. This is the general. This is the second curve. Okay. Now I am taking. Therefore, the general solution is. Therefore, the general solution is some function. Either I am taking pi. Okay. X minus z comma x by y is equal to 0. Okay. So consider another. Yes. You may ask.
ఇక్కడ జనరల్ సొల్యూషన్ అనేది పై ఆఫ్ ఎక్స్.
You can ask your questions at the end of the class. Okay. I will explain. Okay. Yes.
జనరల్ సొల్యూషన్ పై ఆఫ్ ఎక్స్ బై వై కామా ఎక్స్ మైనస్ జెడ్ ఈజ్ ఈక్వల్ 0 కూడా రాయొచ్చు కదా సార్?
As your wish. Okay. It is c1, c2 are arbitrary constant. Pi is also arbitrary constant. You may write pi of x by y comma x minus z equal to 0 also. Okay. Now I am taking.
So excuse me, sir.
Yes, madam.
Sir, in the previous problem, once you took dx by x is equals to dy by y. Again, second time in this problem, sir, you took dy by y is equals to dz by z. So you said that we can take either dx or dz here.
Okay. You may consider here dx by x equal to dy by y. Here I am considering dy by y equal to dz by z. You may take dx by x is equal to dz by z. Okay. So in this case, log x is equal to log z plus arbitrary constant some log c2. That is x equal to c2z. So x by z is equal to c2 is also one solution. Okay. It is also one solution. Now what is the required right option means we have to see the options, given options. What are the given options? We have to check. We can take the right option. Okay. This is also one solution even though. Okay. Yes. Is it clear, madam?
Yes, sir. Thank you, sir.
Okay. Now I am taking another problem. It is from gate. Is from gate. The general solution of the equation tan x p and x into p plus tan y into q is equal to tan z is equal to tan z, where small p is equal to dou z by dou x and small q is equal to dou z by dou y is. So procedure is same. Okay. Here we can write the capital P value tan x and the capital Q value tan y and capital R value tan z. Now the corresponding auxiliary equations are dx by p, that is dx by tan x is equal to dy by tan y is equal to dz by tan z. Okay. Now we can consider, first I am considering dx by tan x is equal to dy by tan y. By integration, you get it is nothing but cot x into dx. One more step I am writing. This is nothing but cot y into dy. By integration, we will get to log sin x is equal to log sin y plus arbitrary constant log c1. So we can write here log sin x is equal to log c1 into sin y. That is sin x is equal to c1 sin y, and sin x by sin y is equal to c1. This is the first column. Okay. Next, I am considering dy by tan y is equal to dz by tan z. You may consider dx by x equal to dz by tan z, like previous one. Okay. So it is nothing but cot y dy is cot z dz. By integration, you get a log sin y is equal to log sin z plus arbitrary constant log c2. That is nothing but sin y is equal to sin z into c2. This is sin y divided by sin z is equal to c2 be the second curve or second general solution. Therefore, we can write the general solution. General solution is some function. I am taking I. Okay, either maybe pi or maybe f, whatever the function. That is sin x by sin y comma sin y by sin z is equal to 0. This is the general solution of the given partial differential equation. Now I am taking, these are the problems related to grouping. Okay, and these are the previous problems. And I am taking one more problem from JL. The solution of the equation, simply asking equation y minus z into p plus z minus x into q is equal to x minus y is. Okay. First, it is not easy to solve in method of grouping, so we need to choose to solve this equation. We need to choose method of multipliers. Method of multipliers means we have to choose, first we have to choose L1, M1, N1 such that L1P plus M1Q plus N1R is equal to 0. We need to choose L1, M1, N1 such that this condition is meets. L1P plus M1Q plus N1R equal to 0 ఏంటంటేగా మనమే చూస్ చేసుకోవాలి. We have to select L1, M1, N1 and these L1, M1, N1 are called multipliers. These are called multipliers. Whenever we are choosing L1, M1, N1 such that L1P plus M1Q plus N1R equal to 0, then L1 into dx plus M1 into dy plus N1 into dz is equal to 0 gives one curve. Call it as L1x plus M1y plus N1z is equal to some arbitrary constant C1. Okay. We have to choose L1, M1, N1 such that this condition is holds. Whenever this condition is holds, then L1 dx plus M1 dy plus N1 dz equal to 0. Similarly, again choose another multipliers, not same as L1, M1, N1. I am choosing L2, M2, N2 such that L2P plus M2Q plus N2R is equal to 0. We have to choose L2P plus M2Q plus N2R is equal to 0. Whenever it is 0, then L2 into dx plus M2 into dy plus N2 into dz is equal to 0. This gives another curve, call it as L2x plus M2y plus N2z is equal to some arbitrary constant to C2. So the combination of these two curves of arbitrary function will give the required solution. This is the procedure to find the general solution of the corresponding linear PDE by using Lagrange's method. It is also called the method of multipliers. Okay. Now you have to remember we need to choose. Choosing is very important. How to choose L1, M1, N1? The linear combination L1P plus M1Q plus N1R equal to 0. Again, we have to choose another multipliers L2, M2, N2 such that the linear combination has 0. Okay. So, then whenever it is 0, L1 into dx plus M1 into dy plus N1 into dz equal to 0. And whenever L2P plus M2Q plus N2R equal to 0, then L2 dx plus M2 dy plus N2 dz equal to 0. Okay. Now after integration, we'll get the curve that is in the form of function of L2, M2, N2 is equal to C2. Some another function of L1, M1, N1 into is equal to C2. Okay, is equal to some C1. This is the first. This gives the first curve, and this gives the second curve. Okay, this is the procedure to solve the partial differential equation by using method of multipliers. First, I'm comparing this equation. Now come back to this problem. Now I'm comparing this equation with the PP plus QQ is equal to R. So the P, capital P value, that is y minus z, and capital Q is equal to z minus x, and capital R is equal to x minus y. Okay. Okay, ఇక్కడ మనం ఆప్షన్ చూస్తే కొన్నిసార్లు మనం డైరెక్ట్ టిక్ పెట్టవచ్చు అంటే నేను చెప్తాను. ఓకే, ఫస్ట్ ప్రాబ్లం కాబట్టి ప్రొసీజర్ కోసమని నేను ఆప్షన్స్ రాయలేదు. ఓకే, ఫస్ట్ we have to choose first our target L1, choosing L1. I am writing here choose L1 is equal to M1 is equal to N1 is equal to such that this is such that the condition is L1P plus M1Q plus N1R is equal to 0. Okay. If you take L1 equal to 1, what happens? L1P is y minus z, and M1 equal to 1, M1Q is z minus x. Here y minus z to minus z minus x no plus z will be cancelled. Then we can take N1 equal to 1. So here plus x, here minus x will be cancelled. Here minus y, here plus y will be cancelled. So this condition is false when we are choosing L1, M1, N1 as 1, 1, 1. Okay, ilane choose chesukovalani ledandi, as your wish. You can choose another terms also because it contains an infinitely many solutions. Whenever L1P plus M1Q plus N1R is equal to 0, then we can write L1 into dx plus M1 into dy plus N1 into dz is equal to 0. So L1 value is 1 into dx. This is dx. I'm writing one more step also. 1 into dx plus 1 into dy plus 1 into dz is equal to 0. Now by integration, we'll get x plus y plus z is equal to some arbitrary constant to C1. This is the first curve of the given partial differential equation. Now we can choose L2, M2, N2. Can choose again, choose L2 is equal to M2 is equal to N2 is equal to, okay, such that we have to choose L2P, L2M2, N2 such that L2P plus M2Q plus N2R is equal to 0. Okay, మళ్ళీ సేమ్ టర్మ్స్ తీసుకోకూడదండి. వన్ మళ్ళీ సేమ్ టర్మ్స్ తీసుకోకూడదు. We can choose other than 1 సేమ్ టర్మ్స్ తీసుకుంటే సేమ్ కర్వ్ వస్తుంది. ఫస్ట్ ఐఎమ్ టేకింగ్, okay, this is assumption only. Okay, how to choose అనేది assumption. It is I'm taking x. Okay, you can practice on rough also. Okay, if you take x, then L1P is xy minus y xz. If you take q equal to y, M2 is equal to y, then you get yz minus xy. Here plus xy, here minus xy will be cancelled. So remaining here yz, here minus xz. So you can take z here. When we take z, here plus zx minus xy, here plus xy will be cancelled. So that's why we are choosing L2 is equal to x, M2 equal to y, N2 is equal to z. Therefore L2 into dx plus M2 into dy plus N2 into dz is equal to 0. We have to remember. So L2 is equal to x dx, M2 equal to y dy plus N2 equal to z dz. Now by integration, we get x square by 2 plus y square by 2 plus z square by 2 is equal to some arbitrary constant, another arbitrary constant C2. Therefore, we can write it as x square plus y square plus z square is equal to C2. Okay, this is the method of multipliers. Okay, now I am taking another problem from JL. This from JL. The solution
రాయాలి కదా సార్ పై ఏమో ప్రాబ్లం.
Yes, I'm sorry. You can find the solution. The
method of multipliers use చేయాలి ఎప్పుడు ఫైనల్ Lagrange's method.
Therefore the general solution is some function of phi of first term is what we have, x plus y plus z. Okay, you may take x square. I'm taking like this, x square plus y square plus z square. Second term is x plus y plus z is equal to 0. This is the general solution of the given differential equation.
ఏ టైంలో method of multipliers use చేయాలి?
మెథడ్ ఆఫ్ మల్టీప్లైర్స్ ఎప్పుడు యూజ్ చేస్తామంటే మెథడ్ ఆఫ్ గ్రూపింగ్ లో రావట్లేదంటే మెథడ్ ఆఫ్ మల్టీప్లైర్స్ యూజ్ చేయాలి. అంటే ఒక కర్వ్ అనేది మెథడ్ ఆఫ్ మల్టీప్లైర్స్ లో రావచ్చు, ఒక కర్వ్ అనేది మెథడ్ ఆఫ్ గ్రూపింగ్ లో రావచ్చు. ఓకే, అకార్డింగ్ టు ప్రాబ్లం we can choose, okay, by practice. Okay, now I am taking one problem from JL. The solution of x into y minus z p plus y into z minus x into q is equal to z into x minus y. Okay, ఈ ప్రొసీజర్ లో మనకు ఆప్షన్స్ మీద ఎక్కువ డిపెండ్ కావాల్సి ఉంటుంది. ఓకే, ఆప్షన్స్ మనకు సగం ఆన్సర్ ఇచ్చేసేయండి. ఫస్ట్ ఆప్షన్ ఐఎమ్ గెటింగ్ phi of x plus y plus z comma xyz is equal to 0. First option. Second option, phi of x plus y plus z comma x square plus y square plus z square is equal to 0. Third option, phi of xy comma yz, xy comma yz is equal to 0, and fourth option phi of x plus y comma x plus y plus z is equal to 0. Okay, first we had to write the capital P value, x into y minus z, capital Q value, y into z minus x, capital R value, z into x minus y. ఓకే, ఇక్కడ మనం ఆప్షన్స్ అబ్జర్వ్ చేయండి. ఫస్ట్ ఆప్షన్ లో x ప్లస్ వై ప్లస్ జెడ్, ఈ x ప్లస్ వై ప్లస్ జెడ్ ఎప్పుడు వస్తుందండి? L1 ఈక్వల్ టు 1, M1 ఈక్వల్ టు 1, N1 ఈక్వల్ టు 1 తీసుకున్నప్పుడు x ప్లస్ వై ప్లస్ జెడ్ వస్తుంది. కాబట్టి ఇక్కడ 2 సార్లు ఉందండి ఆప్షన్, కాబట్టి ఫస్ట్ ఇది చెక్ చేద్దాం. ఓకే, ఇది సాటిస్ఫై అవుతుందా లేదా. ఎక్స్ తీసుకున్నాను, 1 తీసుకున్నాను ఇక్కడ, అంటే 1 తో మల్టిప్లై అయ్యింది. ఇది మల్టిప్లై చేస్తే ఇక్కడ టర్మ్ ఏమవుతుంది? xy మైనస్ xz అవుతుంది. దీన్ని కూడా 1 తో మల్టిప్లై చేస్తే yz మైనస్ xy అవుతుంది. ఇది కూడా 1 తో మల్టిప్లై చేస్తే zx మైనస్ yz అవుతుంది. yz xy xy xz xz అన్ని క్యాన్సిల్ అవుతాయి. కాబట్టి x ప్లస్ y ప్లస్ z, దట్ ఈస్ L1 is equal to 1, M1 is equal to 1, N1 is equal to 1 అనేది సాటిస్ఫై అవుతుంది. అంటే ఈ 2 ఆప్షన్స్ కావాలి, ఇందులో లేవు కాబట్టి ఈ 2 కావాలి. ఓకే, నెక్స్ట్ ఈ కరువుతో మనం చెక్ చేసుకున్నాం కాబట్టి ఈ కరువు వదిలేసేయండి. ఓకేనా, నెక్స్ట్ XYZ, ఇంకోటి x² ప్లస్ y² ప్లస్ z². ఇప్పుడు x² ప్లస్ y² ప్లస్ z² ఎప్పుడు వస్తుంది అంటే L1 is equal to x, M1 is equal to y, N1 is equal to L1 equal to x, M1 equal to y, N1 equal to z తీసుకున్నప్పుడు ఆప్షన్ వచ్చేస్తుంది. కాబట్టి నేను ఈ రెండిట్లో ఏదైనా ఒకటి చెక్ చేసుకుంటాను. ఫస్ట్ ఐఎమ్ టేకింగ్ x తో మల్టిప్లై చేస్తాను, దట్ ఈస్ L2 is equal to, ఒక పని చేద్దాం, వాల్యూస్ ఇక్కడ రాద్దాం కాకుండా మనం చదువుకునేటప్పుడు. This is xy minus xz plus yz minus xy plus zx minus yz. All are cancelled. So this is the solution of the first equation. Now I am taking L2 is equal to 1 by x, M2 is equal to 1 by y, N2 is equal to 1 by z అని తీసుకుంటున్నాం. అంటే దీన్ని x తో డివైడ్ చేస్తున్నాం అంటే అప్పుడు టర్మ్ ఏముంటుంది? yz ఉంటుంది. ఇక్కడ y తో డివైడ్ చేస్తున్నాం, z మైనస్ x ఉంటుంది. ఇక్కడ z తో డివైడ్ చేస్తున్నాం, x మైనస్ y ఉంటుంది. ఓకే, ఇప్పుడు ఈ టర్మ్స్ అన్ని కూడా క్యాన్సిల్ అయిపోతే చూడండి, x x, నెక్స్ట్ z z, y y, ఆల్ ద టర్మ్స్ ఆర్ క్యాన్సిల్. సో 1 by x, 1 by y, 1 by z అనేది choosing. These are the multipliers. So we have formula L2 dx plus M2 dy plus N2 dz equal to 0. That is L2 equal to 1 by x dx, M2 equal to 1 by y dy plus M2 equal to 1 by z dz equal to 0. Okay, so by integration this is log x and this is log y, and log z is equal to arbitrary constant. One is completed, I am taking C2. This is log m plus log n formula, that is log xyz. Log xyz is equal to log C2. That means xyz is equal to C2. That is second curve is xyz. Okay, already x plus y plus z ఒక కర్వ్ అయిపోయిందండి. రెండిట్లో ఈ రెండు కరెక్టే. ఇందులో xyz ఎక్కడ ఉంది? ఫస్ట్ ఆప్షన్ లో ఉంది కాబట్టి ఫస్ట్ ఆప్షన్ చెక్ చేసుకోవాలి. ఓకే, కొన్నిసార్లు ఒక కర్వ్ సేమ్ ఇస్తాడండి, అంటే ఫస్ట్ కర్వ్ x ప్లస్ వై ప్లస్ జెడ్, ఎక్స్ ప్లస్ వై ప్లస్ జెడ్, ఎక్స్ ప్లస్ వై ప్లస్ జెడ్, ఎక్స్ ప్లస్ వై ప్లస్ జెడ్ ఇస్తాడు. సెకండ్ కర్వ్ నే చేంజ్ చేస్తాడు. సెకండ్ కర్వ్ చేంజ్ చేసినప్పుడు we need to find one curve find out చేస్తే సరిపోతుంది. ఏదైతే సాటిస్ఫై అవుతుందో L1p plus M1q plus N1 are equal to 0 ని సాటిస్ఫై చేస్తుందో ఆ కర్వ్ నే మనకు జనరేట్ చేస్తుంది. ఓకే, నౌ ఐ యామ్ టేకింగ్ another problem. general solution of this from PL is not related with multipliers. The general solution of the equation of the 1 minus x into p plus 2 minus y into q is equal to 3 minus z is. ఇక్కడ చూడండి మల్టీప్లైస్ యూజ్ చేస్తే 1 1 1 తీసుకుంటే క్యాన్సిల్ అవుతుందా? ఎక్కడ కూడా క్యాన్సిల్ కావండి. 1 ప్లస్ 2 ప్లస్ 3 లేదంటే ఎక్స్ తో డివైడ్ చేయడానికి కూడా ఛాన్స్ లేదు ఎక్స్ వై తో. కాబట్టి we can go for grouping method. Okay, so first I'm writing p value. Okay, 1 minus x, 2 equal to 2 minus y, r equal to 3 minus z. Okay, every time no need to write on exam. Okay, for our convenient I'm writing the p, q, r values. Just write the corresponding auxiliary equations. Dx by 1 minus x equal to dy by 2 minus y is equal to dz by 3 minus z. Now we can consider dx by 1 minus x is equal to dy by 2 minus y. These two terms contains only xy terms only. So by integration we'll get minus log 1 minus x is equal to minus log 2 minus y plus arbitrary constant log c1. Okay, we may take minus c1 also. Okay, it is an arbitrary, so that we can take minus c1 also. So here log 1 minus x is equal to log 2 minus y plus log c1 multiplying with minus. So 1 minus x is equal to some c1 into 2 minus y. So we can write this as 1 minus x divided by 2 minus y is equal to arbitrary constant c1. Next, consider the another, for another curve I am consider dy by 2 minus y is equal to dz by 3 minus z. Okay, so here minus log 2 minus y is equal to minus log 3 minus z. We may take log minus log c2. That is nothing but log 2 minus y is equal to log 3 minus z plus arbitrary constant log c2 when we are multiplying with the minus. So 2 minus y is equal to 3 minus z into c2. That is 2 minus y divided by 3 minus z is equal to c2 is the second curve. We can write the general solution. Therefore, the general solution is some function pi of 1 minus x by 2 minus y comma 2 minus y by 3 minus z is equal to 0. అయితే ఆప్షన్ లో ఈ ఆప్షన్ లేదండి, సారీ ఆప్షన్స్ రాయలేదు. ఓకే, ఆప్షన్ లో ఎలా ఉంది అంటే 1, this can be written as 1 minus x by 2 minus y is equal to some function of 2 minus y by 3 minus z. ఈ విధంగా కూడా రిప్రజెంట్ చేసుకోవచ్చు. f of uv is equal to 0 or u is equal to f of v. ఇంకా డీటెయిల్ ఇంకేమన్నాడు అంటే దీన్ని 1 minus x is equal to 2 minus y into pi of 2 minus y divided by 3 minus z. Okay, now therefore 1 is equal to x plus 2 minus y into pi of 2 minus y by 3 minus z. ఇక్కడ వరకు సింప్లిఫై చేశాడు ఆప్షన్ ఇక్కడ 1 equal to 1 equal అన్ని కూడా 1 equal to ఒకసారి ప్లస్ ఒకసారి మైనస్ ఉంది. options. Okay. Now this is related with the grouping. Okay. Now I am taking another problem from JL. From JL, I am taking the general method of solving. The general method of solving linear partial differential equation. Linear partial differential equation. Differential equation of order 1 is known as. Okay, we have options. First option is Lagrange's method. Second option is Monge's method. And the third option is Jacobi's method. And the fourth option is Chopis. Okay, these are the methods in partial differential equation. We will see later. The first order linear PDE of order 1. The order 1 means it is in the form of PP plus QQ is equal to R. I am writing clearly. The first order linear PDE. The first order linear PDE is PP plus QQ is equal to R. Okay, this is the first. Of course, it is some function of, I am taking small f of x, y, z, pq is equal to 0. First order and first order linear partial differential equation. Okay. Now for first order, we should use only Lagrange's method. Okay, only Lagrange's method. The Monge's method is used to more than 1 degree, that is 2 or more. Okay, and the Chopis method is used to non-linear partial differential equations. Chopis method is used to find the solution of non-linear partial differential equation, and Jacobi's method is the application of Chopis method. Okay, this is for second order, and this is application of Chopis. This is for non-linear. So our right option is Lagrange's method only. Okay. Now I am taking another question from set. The general solution of the equation y plus zx into p plus minus x plus yz into q is equal to x square minus y square with the usual notations. Notations means small p equal to dou z by dou x and small q is equal to dou z by dou y. Okay, we have options here. I'm writing options here one by one. Option A, function of f of x square minus y square minus z square x plus y plus z is equal to 0. And option B, f of x square plus y square plus z square comma x plus z is equal to 0. Option C, f of x square plus y square minus z square xy plus z equal to 0. And option D, f of x square minus y square minus z square xy minus z equal to 0. These are the options we are given. Okay, you can check one by one options. We can depend options. First, before checking the options, first we need to write the capital P value, capital Q value, capital R value equal to y plus zx, Q is equal to minus of x plus yz, R is equal to x square plus y square. Okay, ఆప్షన్స్ చెక్ చేసుకోండి. x స్క్వేర్ అంటే x తీసుకోవడం, x ప్లస్ y ప్లస్ z అంటే 1 1 1 తీసుకోవడం.
Excuse me, sir. R is equals to x square minus y square, కదా?
Yes, x square minus y square. Okay, x plus y plus z అంటే 1 1 1 చూస్ చేసుకోవడం అండి. ఇక్కడ x స్క్వేర్ మైనస్ y స్క్వేర్ మైనస్ z స్క్వేర్ అంటే x మైనస్ y మైనస్ z. ఇక్కడ అన్ని ప్లస్ x y z. ఇక్కడ x y మైనస్ z. ఇక్కడ x మైనస్ y మైనస్ z. ఓకే, x ప్లస్ z అంటే 1. ఓకే, we can consider this is in grouping వచ్చేస్తా. లేదంటే ఇక్కడ p equal to y, q equal to x తీసుకోవాలి. d of x y z n2 equal to 1 తీసుకుంటాం. ఓకే, దిస్ ఈస్ ద మెథడ్స్. ఫస్ట్ 1 by 1 చెక్ చేద్దాం. మనం ఫస్ట్ ఒక ఆప్షన్ చెక్ చేద్దాం, ఇంకో ఆప్షన్ డైరెక్ట్ పెట్టేయచ్చు. ఫస్ట్ ఐఎమ్ చూసింగ్ L1 is equal to M1 is equal to N1 is equal. ఇక్కడ ఉన్న ఆప్షన్స్ చూస్ చేసుకుందాం. ఓకే, అవి కరెక్ట్ అయితే సెలెక్ట్ చేద్దాం, లేదంటే ఇంకో ఆప్షన్కి వెళ్ళిపోతాం. ఫస్ట్ అన్ని ప్లస్లు ఉన్నాయి కదా, సరే ఇదే తీసుకుందాం. ఎక్స్ ఇదే చెక్ చేయాలని ఏం లేదు, మీ ఇష్టం ఏదైనా తీసుకోండి. మైనస్ వై ఎక్స్ మైనస్ వై N1 is equal to మైనస్ జెడ్. ఓకేనా, ఇది ఆప్షన్స్ చూస్ చేసుకుందాం. ఇవి సాటిస్ఫై అయితే ఎలాగా చూడాలి అంటే వీటితో మల్టిప్లై చేసి యాడ్ చేస్తే లీనియర్ కాంబినేషన్ 0 రావాలి. ఫస్ట్ ఎక్స్ తీసుకుంటే ఒక టర్మ్ ఏమవుతుంది, ఎక్స్ వై ప్లస్ జెడ్ ఎక్స్ స్క్వేర్ అవుతుంది. నెక్స్ట్ మైనస్ తీసుకున్నప్పుడు ఇది ప్లస్ అయిపోతుందండి. అప్పుడు ఎక్స్ వై ప్లస్ వై స్క్వేర్ జెడ్ అవుతుంది. నెక్స్ట్ మైనస్ జెడ్ తీసుకుంటే మైనస్ జెడ్ ఎక్స్ స్క్వేర్ మైనస్ ఆఫ్ మైనస్ ప్లస్ వై స్క్వేర్ జెడ్. ఎక్స్ వై కూడా క్యాన్సిల్ కావట్లేదండి ఇక్కడ. అఫ్ కోర్స్ వై స్క్వేర్ జెడ్ కూడా క్యాన్సిల్ కావట్లే, జస్ట్ ఎక్స్ స్క్వేర్ జెడ్ ఒకటే క్యాన్సిల్ అవుతుంది. కాబట్టి ఈ ఆప్షన్ తీసుకోవద్దు. ఓకే, నెక్స్ట్ అన్ని ప్లస్లు తీసుకుందాం అండి. ఓకే, మనం చెక్ చేస్తున్నాం అంతే, రఫ్ గా చెక్ చేసుకుంటున్నాం. అంటే ఎక్స్ ఈజ్ ఈక్వల్ L1 ఈక్వల్ టు ఎక్స్, M1 ఈక్వల్ టు ప్లస్ వై తీసుకుంటాను. ఇక్కడ ఉన్నాయి, ఎందుకు ఇలానే చూస్ చేసుకుంటున్నా అంటే ఆప్షన్స్ నుండి చూస్ చేసుకుంటున్నా. ఇక్కడ ప్లస్ తీసుకుంటాం, అన్ని ప్లస్ తీసుకుంటే ఇక్కడ ఏమొస్తుంది, ఇది ప్లస్ ఏ ఉంటుంది, కరెక్ట్ ఇలానే ఉంటుంది. ఇక్కడ కాస్త మైనస్ వస్తుంది, మైనస్ ఎక్స్ వై. ఇది కూడా ఏమవుతుంది అప్పుడు మైనస్ వై స్క్వేర్ జెడ్ అవుతుంది. ఇక్కడ ప్లస్ వస్తుంది, ఇదేమో మైనస్ అవుతుంది. ఓకేనా, అప్పుడు ఏం క్యాన్సిల్ అవుతాయండి, సరే క్యాన్సిల్ కానీ చూడండి, వై స్క్వేర్ జెడ్ క్యాన్సిల్ కాదండి. ఓకే, కాబట్టి నేను ఇంకొక ఆప్షన్ ఉంది ఇక్కడ మన దగ్గర, అంటే ఇది కరెక్ట్ కాదు, ఫస్ట్ ఆప్షన్ కరెక్ట్ కాదు, అయిపోయింది. ఏ ఆప్షన్, బి ఆప్షన్ దగ్గర కూడా కరెక్ట్ కావట్లేదు. నెక్స్ట్ అంటే ఫస్ట్ ఒక కరువు కావాలి, దెన్ we go for another curve. Okay, ఒక కర్వ్ కావట్లేదు కాబట్టి సొల్యూషన్స్ కాదు. నౌ ఐఎమ్ గోయింగ్ ఫర్ దిస్. ఫస్ట్ x ఉంది ఇక్కడ y, ఇక్కడ ఏమొస్తుంది మైనస్ z రావాలి తీసుకుంటా. అప్పుడు x తీసుకుంటే xy ప్లస్ zx² యాజ్ దిస్, ఇక్కడ ప్లస్ తీసుకున్నాం కాబట్టి మైనస్ xy మైనస్ y² యాజ్ దిస్, ఇక్కడ మైనస్ తీసుకున్నానండి కాబట్టి ఇక్కడ ఏమొస్తుంది మైనస్ zx² మైనస్ మైనస్ ప్లస్ y²z. ఇప్పుడు క్యాన్సిల్ అవుతున్నాయా చూడండి. y²z x² z x²z xy ఇక్కడ క్యాన్సిల్ సాటిస్ఫై అవుతుంది. కాబట్టి దిస్ ఈస్ ద సొల్యూషన్ xy మైనస్ z. సో xy మైనస్ z ని ఇంటిగ్రేషన్ చేస్తే ఏమొస్తుంది x²/2 y²/2 మైనస్ z²/2. ఓకే, 2 అవుట్ సైడ్ వెళ్ళిపోతుంది కాబట్టి x² ప్లస్ y² మైనస్ z² ఈక్వల్ టు c1 సమానం ఉంటుంది కాన్స్టెంట్. ఈ ఆప్షన్ తోటి ఇంకేదైనా ఆప్షన్ ఉందనుకోండి, ఫస్ట్ ఆప్షన్ అంటే x² ప్లస్ y² మైనస్ z² తోటి ఇంకో కండిషన్ ఉందనుకోండి, ఇక్కడ ఉందనుకోండి, అప్పుడు సెకండ్ ఆప్షన్ చెక్ చేయాలి. ఇక్కడ వరకు స్టాప్ చేస్తే అయిపోతుంది. ఇస్ ఈక్వల్ టు 0 కాబట్టి therefore sum L1 dx plus M1 dy plus N1 dz is equal to 0. That means L1 equal to, we are taking x dx, this is plus y dy, this is minus z dz is equal to 0. By integration get x²/2 plus y²/2 minus z²/2 is equal to arbitrary constant sum c1. x² plus y² minus z² is equal to c1. ఈ కరువు తోటి ఒకటే ఆప్షన్ ఉందండి మన దగ్గర, x² plus y² minus z² తోటి ఒకటే ఆప్షన్ ఉంది కాబట్టి you can choose this is the right option. No need to check next option. Okay, చెక్ చేయాల్సిన అవసరం లేదు. ఇక్కడికి స్టార్ట్ చేసి
ఎక్స్క్యూజ్ మీ సార్.
yes మేడం.
సార్ ఆల్రెడీ మనం అవి x² y² z² కోఎఫిషియంట్ తీసుకుంటే సాటిస్ఫై అయినప్పుడు మళ్ళీ ఫార్ములాలో సబ్స్టిట్యూట్ చేసి మళ్ళీ దాన్ని కనుక్కోవడం ఎందుకు సార్?
అంటే ఫర్ కన్వీనియంట్ మీకు, అంటే ఇది ఎలా వచ్చింది అని చెప్పడం కోసం ఇక్కడే నేను ఆల్రెడీ టిక్ పెట్టేశానండి ఇక్కడే. ఓకేనా, ఇక్కడ వరకు చెప్పేసి 0 అయింది కాబట్టి అవర్ రైట్ ఆప్షన్ ఈస్ దిస్ అని చెప్పేసిన. దిస్ ఈస్ ద ఎక్స్ట్రా వర్క్, మనకు ఎలా వచ్చిందని చెప్పడం కోసం ఇది ఎక్స్ట్రా వర్క్ అంటే. ఓకే, నో నీడ్ టు ఫైండ్. ఓకే, జస్ట్ ఎక్కడైతే సాటిస్ఫై అవుతున్నాయో వాటిని ఇంటిగ్రేషన్ చేయడం అంతే. ఓకేనా మేడం?
సార్ ఎక్స్క్యూజ్ మీ సార్.
ఓకే సార్
సార్ xy ప్లస్ z కి L1 M1 N1 ఎలా తీసుకోవచ్చు సార్ చెప్తారా?
xy
ప్లస్ z ఉంది కదా సార్ ఆ సి ఆప్షన్ లో సెకండ్ కర్వ్. సార్ xy ప్లస్ z కి L1 M1 N1
ఓకే సార్. ఓకే, ఇక్కడ నేను చెప్తాను సార్. ఓకే, ఇక్కడ వరకు స్టాప్ చేసి మనం ఆన్సర్ పెట్టేయచ్చు అండి. అదే చెక్ చేద్దాం ఇది ఎట్లా అవుతుంది, సాటిస్ఫై అవుతుందా లేదా చెక్ చేయాలి, అది కూడా ఇంపార్టెంట్. చూసింగ్ L2 M2 and N2. Okay, our condition is such that L2P plus M2Q plus N2R is equal to 0. Therefore L2 dx plus M2 dy plus N2 dz equal to 0. ఇదంతా మనం గుర్తుపెట్టుకోవాలండి. Now I am choosing L2 is equal to y, M2 is equal to x, N2 is equal to 1 తీసుకుంటున్నాను. ఓకే, తీసుకుంటే చూడండి ఇక్కడ ఈక్వేషన్ ఏమొస్తుందో నేను సచ్ దట్ ఇక్కడ రాస్తాను. కండిషన్ ఏం జరుగుతుందో చూద్దాం. ఆల్రెడీ మనం ఆన్సర్ పెట్టేసామండి. ఓకే, మళ్ళీ ఇదంతా ఎందుకంటే ఫస్ట్ ఫర్ అవర్ అండర్స్టాండింగ్ వీఆర్ మల్టీప్లైయింగ్ విత్ p విత్ y అండి. సో ఫస్ట్ టర్మ్ y² plus yzx, first term, plus second term we are multiplying with x అంటే ఇక్కడ మైనస్ ఉంది కాబట్టి మైనస్ రాసేస్తున్నా. x² plus xyz and we are multiplying with 1 plus 1 కాబట్టి x² minus y². Here xyz and yzx both are same. Here plus y² minus x² minus y square plus x square will be cancelled. When they are cancelled, therefore L2 dx plus M2 dy plus N2 dz is equal to 0. Therefore, L2 equal to y dx, M2 equal to x dy plus N2 equal to 1. 1 into dz is dz. So this can be written as d of xy, UV formula, y dx plus x dy nothing but d of xy plus dz is equal to 0. So by integration, we'll get to xy plus z is equal to c2. This is the another curve. Okay, na? Same వచ్చేస్తుందండి. మనం చెక్ చేయాల్సిన అవసరం లేదు. ఒకటే ఆప్షన్ ఉంది అంటే ఒకటి చెక్ చేసి మనం టిక్ పెట్టేయచ్చు. ఓకే, నో ప్రాబ్లం. ఓకే, నో నీడ్ టు చెక్ అనదర్ ఆప్షన్. ఓకే, సేమ్ ఆప్షన్ ఉంది అనుకోండి, ఇక్కడ కూడా ఫర్ ఎగ్జాంపుల్ ఈ రెండు కాలేదు, డి ఆప్షన్ లో కూడా ఇక్కడ ప్లస్ ఉంది అనుకోండి, ఒకవేళ ప్లస్ ఉంటే అప్పుడు ఇది చెక్ చేయాల్సి వస్తుంది. ఓకే, కాబట్టి ఫస్ట్ ఆప్షన్ తోటి మనం టిక్ పెట్టేయచ్చు. ఓకేనా సార్?
ఓకే సార్, థ్యాంక్ యూ సార్.
Now I am taking another problem. This from DL. The general solution of of the PDE of the partial differential equation x into y square minus z square p minus y into z square plus x square into q is equal to z into x square plus y square is. Okay, these are the this is the problem. Now first I am writing p value x into y square minus z square, q value minus y into z square plus x square, and r value z into x square plus y square. Okay, if you divide ఇక్కడ x y z ఉన్నప్పుడు డివైజన్ అనేది గుర్తుపెట్టుకోండి, లేదంటే xyz ఇలా అంటే ఆటోమేటిక్ గా అయితే ప్లస్ x minus z whatever the term. Okay, first I am choosing first options 1 by x, ఇక్కడ x తో డివైడ్ చేస్తున్నా, నెక్స్ట్ 1 by y, నెక్స్ట్ 1 by z చూజ్ చేసుకుంటా. ఓకే, ఫస్ట్ కర్వ్ కోసం చూజ్ చేసుకుంటే ఇక్కడ ఏమవుతుంది, y square minus z square first term minus of z square plus x square plus x square plus y square. అన్ని క్యాన్సిల్ అవుతాయండి, చూడండి అన్ని టర్మ్స్ క్యాన్సిల్ అవుతాయా? z square క్యాన్సిల్ కాదు, క్యాన్సిల్ కావట్లేదు, z square క్యాన్సిల్ కావట్లేదు. మైనస్ 1 by y తీసుకోండి, ఇక్కడ మైనస్ 1 by y తీసుకుంటే ఇది ప్లస్ అవుతుంది, ప్లస్ అయినప్పుడు z square క్యాన్సిల్ అయిపోతుంది, y square క్యాన్సిల్ కాదండి. వన్ సెకండ్,
minus 1 by x
మైనస్ 1 by z తీసుకోండి, మైనస్ 1 by z తీసుకుంటే 1 by z తీసుకున్నాను అనుకోండి, ఇక్కడ ఏమవుతుంది x square plus y square ఉంటుంది, మైనస్ ఆఫ్ ఇక్కడ ప్లస్ x square plus y square minus z square plus z square all are cancelled. So this is satisfied the given equation. Okay na? So we can write just integration and the sum of these two. That means 1 by x dx minus 1 by y dy minus 1 by z dz is equal to 0. Now integration log x, this is log y, and this is log z is equal to log some arbitrary constant c1. C1. So log is nothing but log x, when we taking minus common, log m plus log y plus log z, that is nothing but log yz is equal to log c1. That is log m minus log n formula here. So
X by
x by yz is equal to c1. X by yz is equal to c1. Next, second curve. ఇంకో కర్వ్ కావాలి మనకు. ఫస్ట్ ఐ am choosing
XYZ.
y z xyz తీసుకుంటుంది. ఓకే, దిస్ ఈస్ చూసింగ్, వెరీ ఇంపార్టెంట్. నెక్స్ట్ ఇవి కరెక్ట్ అవుతాయా లేదా చెక్ చేసుకోండి. ఫస్ట్ x తో మల్టిప్లై చేసుకోండి. ఇక్కడ ఏమొస్తుంది? x స్క్వేర్ y స్క్వేర్ మైనస్ x స్క్వేర్ z స్క్వేర్ ఫస్ట్ టర్మ్. నెక్స్ట్ మైనస్ ఉందండి, మైనస్ ఆఫ్ y స్క్వేర్ z స్క్వేర్ ప్లస్ y స్క్వేర్ x స్క్వేర్. దిస్ ఇస్ y square x square plus last term is z square x square plus z square y square. Okay, ఇలా టర్మ్స్ వచ్చేసి క్యాన్సిల్ అవుతాయా చూడండి. దిస్ ఇస్ ప్లస్ ప్లస్ మైనస్ విల్ బి క్యాన్సిల్, y square z square. ఓకే, ఆల్ ద టర్మ్స్ ఆర్ క్యాన్సిల్. ఓకే, it is 0. Whenever it is 0, then x into dx, just multiply first term with x, second term with y, and first term with dx, second term with dy, third term with dz. X dx plus y dy plus z dz is equal to 0. Now by integration, we get x square by 2 plus y square by 2 plus z square by 2 is equal to some arbitrary constant c2. Therefore, x square plus y square plus z square is equal to c2 is the equation. Next, second curve. Therefore, the general solution is some function phi of either x by yz comma x square plus y square plus z square is equal to 0. You may write to phi of x square plus y square plus z square comma x by yz is equal to c2 also. Okay, now I am taking
సార్ మనము L1 L2 M2 N2 1 కూడా తీసుకోవచ్చా సార్?
తీసుకోవచ్చు సార్, మనం ఏదైనా తీసుకోండి, మీరు ఎలానే తీసుకోండి. కండిషన్ ఏంటి? L1p plus M1q plus N1r equal to 0 కావాలి, అది కండిషన్. ఆ కండిషన్ సాటిస్ఫై అయ్యేటట్టుగా దీన్ని తీసుకోండి. దిస్ ఈస్ నాట్ ఫిక్స్డ్. Okay, the system consists of infinite many solutions. Okay,
ఓకే సార్.
now I am taking another problem. It is from DL. The general solution కాకుండా జనరల్ ఇంటిగ్రల్ అన్నాడు. జనరల్ ఇంటిగ్రల్ ఆఫ్ xzp of xzp plus yzq is equal to xy is. Okay, first I am writing p value xz, q value yz, r value xy. The corresponding auxiliary equations are dx by xz is equal to dy by yz is equal to dz by xy. Okay, first I am considering dx by xz is equal to dy by yz. While considering these two, z will be cancelled. Only x dx, y dy terms are separated. So just integrate. Log x is equal to log y plus arbitrary constant log c1. That is x is equal to c1y. Therefore, x by y is equal to c1 is the first curve. Next, For example, if we consider dx by xz equal to dz by xy కన్సిడర్ చేసాం అనుకోండి, x క్యాన్సిల్ అయిపోతుంది, z ఉంటుంది, ఇక్కడ y టర్మ్ ఉంటుంది కానీ dy టర్మ్ ఉండదు, కాబట్టి కన్సిడర్ చేయడానికి వీలు. ఓకే, మళ్ళీ సింప్లిఫికేషన్ కష్టం అవుతుంది, మళ్ళీ x ను ఇక్కడ నుండి y ని ఇక్కడ నుండి ఎలిమినేట్ చేయాల్సి. dy by yz ఈక్వల్ టు dz by xy కన్సిడర్ చేస్తే y క్యాన్సిల్ అవుతుంది, కానీ ఇక్కడ y dz dy dz టర్మ్స్ ఉన్నప్పుడు x అనే టర్మ్ ఉంటుంది, కాబట్టి మెథడ్ ఆఫ్ గ్రూపింగ్ లో చేయడం ఈజీ కాదు. సో వీ హ్యావ్ టు చూస్ సమ్ multipliers. Okay, I'm taking the multipliers here. First term is y, second term is x, what happens? That means p into y, that is xyz, plus q into yz, that is x into yz. So yz only, x yz, okay, xyz, this is xyz, xyz. Here we have xy. So if we multiply, ఇక్కడ xyz అంటే ఇక్కడ ఏమొస్తుందండి, 2xyz వస్తుంది. 2xyz క్యాన్సిల్ కావాలంటే ఇక్కడ ఏం తీసుకోవాలి, ఇప్పుడు మనం -2z తీసుకోండి. ఓకే, -2xyz అవుతుంది, కాబట్టి -2xyz, కాబట్టి 0 అవుతుంది. 0 కాబట్టి నౌ therefore L2 సమ్ L, ఇక్కడ L అని తీసుకున్నాం కాబట్టి, లేదంటే సింపుల్ గా డైరెక్ట్ రాస్తున్నా, y ఇంటూ ఫస్ట్ టర్మ్ ఇంటూ dx ప్లస్ సెకండ్ టర్మ్ ఇంటూ dy, థర్డ్ టర్మ్ ఇంటూ dz is equal to 0. So this is nothing but d of xy minus 2z into dz is equal to 0. So xy minus 2z integration z square is equal to c2. This is the second term. Therefore, the general solution is some function of x by y comma xy minus z is equal to 0. This is x. Okay. Okay, today with this I conclude. If you have any question, you can ask. Sir, hello, sir. Sir. Hello. Okay, madam, you can ask. If you have question, you can ask.
Sir, ఇందాక dx by xz is equal to dy by yz is equal to dz by xy కదా సార్, మన auxiliary equation
dx by
and Bolzano-Weier's theorem. Today we'd like to start another topic, sequences. So let me give the definition of sequence. A function. Sequence is nothing but a function. Function from natural numbers to real or complex. In real analysis, we can take real numbers. It's called a function. It's called a sequence. It's called a sequence of real numbers because the codomain is real numbers. We are interested in sequence of real numbers. We are not interested in sequence of complex numbers. So that means you take any number here, that image is a real number, right? That image which I denoted by like this, xn. That means suppose you take 1, what is the image? x1. Suppose you take x2, what is the image? x2. You take 3, what is the image? 3. This is my n. This is my, suppose you consider this is r. So this is my 1. So what is image? x1. You take 2, what is image? x2. You take 3, What is image? X3. If we take 4, what is image? X4. Therefore, these are the terms of the sequences. This is exactly, this is first term. This is a second term. This is exactly third term. Like that going on. So this is about a sequence, right? So generally, this is the definition of a sequence. Next is, see, easily one can see sequence actually in precisely in actually sequence look like this, because actually what is meant by sequence? We have said actually that sequence is a function. What do you mean by function? Function is nothing but a relation. A relation is nothing but what? It's a subset of A cross B, like that. So sequence actually what it's looking like this actually. 1, the image is X1. 2, image is X2. 3, image is X3. 4, image is X4. Like that. Therefore, what you observe is that sequence is always infinite set. Understand? Because these order pairs cannot be equal. 2 order pairs cannot be equal because 1 cannot be 2. These 2 order pairs cannot be equal because 2 cannot be 3. This order pairs cannot be equal because 3 cannot be 4. Therefore, what you observe? Sequence is always an infinite set. Sequence, so notice is sequence is an infinite. Sequence is always infinite. So this is very important notation, because sequence we can think of infinite, right? Suppose you take an example. I'm going to take this. S is equals to, suppose my sequence is like this. That means what? N equals to 1 means 1, n equals 2 means 2, n equals 3 means 3, n equals to 4 means 4. So that means this is my sequence. Here my first term, this is my second term, this is my third term, this is my fourth term, this is my fifth term. So this is a sequence which is an infinite sequence. Suppose you take this, S is equals to, suppose, -1 whole power n. This is my sequence. What is my sequence? Suppose you take n equals to 1, -1, n equals 2 means what? -1 whole square, that means 1. N equals 3 means what? -1 whole cube means -1. Like this, -1, 1, -1, 1. So this is my sequence. See, it is repeating -1, 1, -1, 1, -1, 1. It's not finite set because -1 is an image of one element. 1 is an element image of 2. 3 is an image of, see, -1 is image of 3. Therefore, it's infinite set. It's looking like that, okay. But the thing is, you can understand that it is always infinite set. It is always infinite set.
Excuse me, sir.
Yeah. Yeah.
Hello, sir.
Yeah, tell me. Yeah.
Sir, can you show in diagram this second example?
Yes. Why not? So what is my domain of the function? Like this.
Domain is -1 power.
No. What is my domain of the sequence?
Natural
Natural
numbers.
numbers. So what is the codomain here? Real numbers. So what is the first image? -1. So here, this is -1. So what is the second element?
1.
1. So 2 against 1. Here 1 is there. 2 against 1. This is 2, 1. 3 means again here. 4 means here. 5 means again here. 6 means again here. 7 means again here. Like that. So this is what my sequence. That's what my telling. Sequence is nothing but what? Sequence is always infinite. It's nothing but order pairs. So it's always infinite set. Right? Suppose you take this 1 over n. This is also my sequence. Right? What is my first term? 1 by 1, 1, 1 by 2, 1 by 2, 3. When you take n equals to 3, you are going to get 1 by 3, you take 4, 1 by 4, take 5, 1 by 5, take 6, 1 by 6. So this is my sequence. Of course, you can plot the sequence in a diagram. Suppose you take this. What is my domain actually? This is my domain. This is my 1, 1, 1. Because one image is 1. What is my 2 image? 2 image is 1 by 2. 1 by 2 is somewhere here. 3 image is 1 by 3. Here. 4 image is 1 by 4. 5 image is 1 by 5. Like this, it tends to 0. So this is my sequence. Suppose you take this. N is equals to -1 whole power n by n. Right? So what is my sequence here? You take n equals to 1, -1. N equals to means what? 1 by 2. N equals 3 means what? 1 by 3. N equals to 4 means what? 1 by 4. N equals to 5 means what? -1 by 5. N equals to 6 means what? 1 by 6. Like that going on. In a real line, it is looking like this. Suppose n equals to -1 means here. N equals to 1 means what? -1. N equals to 2 means what? 1 by 2. N equals to 3 means what? -1 by 3. N equals to 4 means what? 1 by 4. N equals to 5 means what? -1 by 5. N equals to 6 means what? 1 by 6. It towards 0. So therefore, the sequence we'll see later converges to 0. Right? If you take a constant sequence, suppose you take constant sequence. This plays very, very important role, constant sequence. A sequence is said to be constant. Sequence of real numbers you need to understand, because we are working with real analysis, not complex analysis. Sequence of real numbers. When I mean sequence, you need to understand that it's a sequence of real numbers. Is it to be constant sequence? If and only if there exists a real number, all the terms are is a constant function. That means what? All the terms should be constant. For every n belongs to n. First term 1, first term constant. Second, S1 1k, S2k, S3k, S4k, S5k, S6k, 7k, going on, going on, going on. So this is what constant sequence. All the terms should be constant. Next is eventually constant. This term is very, very important. Eventually constant. Because these two sequences always convergent with respect to any metric, any topology. So eventually constant. Eventually constant means a sequence Sn is said to be eventually constant. If and only if there exists at least a stage. We call the stage is, for example, n, such that after the stage all the terms are constants. Suppose it is very constant k. After the stage, after the kth stage, all the terms are constant. That means I don't know about S1, I don't know about S2, I don't know about S3. Up to I don't know Sn minus 1. But after nth stage, all the terms are constant. This is my eventually constant sequence. This is very important. Why? Because this is always convergent with respect to any metric, any topology. Example, suppose you take this. Suppose you take this. Is it constant sequence? Yes, because all the terms are equivalent. Is it eventually constant? Yes, because I adjust n equals to 1. I can choose n equals to 1. After n equals to 1, of course include in 1, all the terms are 1. Therefore, it is also eventually constant also. Is constant, of course, eventually constant. Because I can choose a stage n equals to 1. Of course, you can choose n equals 2 also, no problem. Of course, somebody choose n equals to 3, no problem. So therefore, this is what eventually constant sequence. Right? Suppose you take this example, second example. Suppose let me take 1 by n. Is it eventually constant? No, because all the terms are different. You take any stage. We take any stage. All the terms are different. There is no k, 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 k. So it's not my eventually constant sequence. Is it constant? Is it constant sequence? No. Because it's not eventually constant means what? Cannot be constant sequence. So what is your notice? Notice is every constant sequence is always eventually constant sequence. You take any constant sequence that is always eventually. This is example. You have given one example, example 1. But what about the converse? Converse may not be true. Why? Suppose I'm going to take this sequence 1, 2, 3, 100, 101, 101, 101, 101, 101, 101, going on. Is it constant sequence? No. These two terms are different. What is my constant sequence? Every term, all the terms are equal. All the terms are equals to some constant. So what about this? 1 cannot be equals to second term. First term cannot be equals to second term. Therefore, this is clearly not a constant sequence. Is it eventually constant sequence? Yes, because I'm going to choose a stage. Suppose you can choose n equals to 1 or 2. So what is my S1 or 3? 101. What is my S1 or 4? S1 or 4 sequence means here. This is 100, 101, 102, 103, 104.
101.
101. S105.
101.
101. That means what you observe? Sn is 101 for every n bigger than equals to 102. See, somebody can choose n equals to 103 also, 104 also. You can choose. What is my definition? My definition tells you that you need to choose at least one stage. There exists at least one stage. After the stage, all the terms are constant. That is what my definition of eventually constant sequence. You can provide at least one stage. After the stage, all the terms are constant. That is why eventually constant sequence. Right? Next is.
Sir, small doubt, sir.
Yeah.
After some stage, constant it should be, no?
Problem. This is not eventually constant. Okay. Next is range of a sequence. Suppose you consider it a sequence. So what is my range of a sequence? You collect all the terms which are in a sequence, which are distinct. That is what range of a sequence. Set of all distinct terms of a sequence is called range of a sequence. That means you collect, this is a set. Range is nothing but a set. What is my range? Range is nothing but a set, amma. You need to be very careful. Range is nothing but a set of all distinct terms. So range of a sequence is nothing but a set consisting of distinct terms. Set consisting of distinct terms. It's a set. It's a set. What is my sequence? Sequence is nothing but a function. Range is nothing but a set. Set of all distinct terms. Suppose, let us consider an example. Simplest example, this. What is my sequence here? 1, 2, 3, 4, 5, 6, going on. This is my sequence. Now, what is my range of a sequence? Set of all distinct terms. 1, 2, 3, 4, 5, 6, 7, 8, like this. So, that is what actually range of a sequence. Suppose you take this. Sn is equals to -1 whole power n, or else you can take like this, -1 whole power n plus 1. So suppose you take n equals to 1, 0, n equals to 2, 2, n equals to 3, again 0, n equals to 4, 2, n equals to 5, 0, n equals to 6, 2. This is my sequence. So what is my range of a sequence?
0 to
Distinct terms. That means 0 and 2 are distinct terms. 0 and 2 are only distinct terms in the sequence. Therefore, this is my range of a sequence. Right? Suppose you take this. Sn is equals to 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So what is my range of sequence?
1, 2, 3, 4, 5, 6.
So set of all distinct terms. 1, 1,
2, 3,
1.
4, 5.
1, 2, 3, 4, 5, 6, 7 is exactly natural numbers. Suppose you take this 1, 2, 3, 4, 1, 2, take 3, again 1, 2, 3, again 1, 2, 3, again 1, 2, 3, like this. So what is my range of a sequence?
1, 2, 3.
1, 2, 3.
1, 2, 3.
Yeah, that's it. So this is about my range of a sequence. Suppose you take this. Range is very, very important. Range plays very, very important role. Already see, because when anyone discuss about the range of a function, it should be bounded. The function should be bounded. We have seen range. When you want to say that something is bounded sequence, you need to show that a range must be bounded. So you need to be very careful about the range of a sequence. Suppose you take this sequence. Sn is a like constant sequence. What is the range of a sequence? Only one. Right? Suppose you take Sn is equals to like sin 1 by n. What is the range of a sequence? Range of a sequence. Anybody? What is the range of a sequence? Sin 1, sin 1 by 2, sin 1 by 3, sin 1 by 4, sin 1 by 5. This is my range of a sequence. Of course, this range is always contained in closed 0, closed 1. We have seen this kind of techniques already, because 0 to 0, see 1 by n is always less than or equals to 1. This is my Stern curve. This is pi by 2. Pi by 2 is nothing but what? 1.1, like this. So sign values in between 1.1 to 1, in fact less than or equals to 1. In fact, 1 less than or equals to 1.1, always increasing function. Therefore, sign values bounded below by 0, bounded above by 1. Therefore, it is contained in close 0, 1. But the range is exactly this. ఎందుకు ఇది ఎగ్జాక్ట్లీ ఈక్వల్ గా అయితే ఈక్వల్ కాదు. అండర్స్టాండ్? ఎందుకు somewhere there are points which are dense number of points which don't have an image. Understand? Here my domain is exactly 1 by n. n natural numbers. 1 by n is my sequence. Okay, this is contained in this. So this is my range. This is not my range. Range is contained in this. Suppose we take this. Sn is equals to sin n. Can you write a range? Use chat box. Use chat box. I'm not. So is it chat box available? Hello? Yeah, -1 to 1. Sin 1 to by good Rojo. Shruti also responded. This 1 to 1, that's also okay. Srilad also responded. Sirisha, of course, responded. Shivakumar responded. Vedavati responded. Yeah, okay. So మళ్ళీ కన్ఫ్యూజ్ అవుతున్నారు. -1 to 1 కాదు. This is 1. Sin 2. Sin 3. Sin 4. Now what is my range? Range is exactly, it's not -1 to 1. Range is exactly this. Of course, it is contained in -1 to 1. But the thing is, range should be this. We are not interested in remaining points. What you are interested? You are interested in only look at the 1, 2, 3. So where you get actually, this is my suppose sine curve is there. Right? This is sine pi is 3 point something. Somewhere it is meeting above. Here. So that means year meeting, year meeting, year meeting. So look at the images. Look at the images. So these images are called as, what is that? Range of a sequence. I'm not interested in this total range because I don't have an image. Because what is my domain? My domain is natural numbers. What is my domain? My domain is natural numbers. So -1 to 1 rasaru, అది wrong. Range is sin 1, sin 2, sin 3, sin 4, sin 5, sin 6. Like that. So what you observe is, notice, range may be finite, may not be finite. Means range of a sequence Sn may be finite or infinite. This is my first notice. Second notice is, if the range is finite, మనం చూసాం -1 whole power n. If the range of a sequence is finite, what I mean by this? There exists a term, at least one term of the sequence which is repeating infinitely many times. Many times. Because range is finite, no? Range finite means what? Some element. Suppose you take this sequence. So what is this actually? -1, 1, -1, 1, -1, 1, -1, 1. So what is my range of a sequence? So only -1 to +1. Range is finite here. Range is finite. But the thing is, whenever range finite, here -1 is located at first place, -1 is located at third place, -1 is located at 5th place. That means -1 is located at odd places. That means -1 is repeating infinitely many odd places. At infinitely many odd places. Therefore, -1 term is repeating infinitely many terms. That's not my point. There exists at least one term of the sequence which is repeating infinitely many times, at least one term. If none of the terms are repeated, means range should be infinite. Suppose you take this sequence. So 1, 2 square, 3 square, 4 square, 5 square, 6 square. None of the term is repeating. What do I mean by this? What is the range of a sequence? Range of the sequence is 1, 4, 9, 16, 25, 36. Range is infinite. Understand? If range is finite, at least one of the term is repeating infinitely many times. So that's what actually thing. Right? Next is bounded below sequence. Bounded below sequence means you take a sequence Sn of real numbers is it to be bounded below only if there exists a term, there exists a real number. In fact, this all the terms are right side to all the sequence terms are right side to that k. This is true for every term. That means we find some k, there exists at least one real number after the real. That means after real number, all terms are there. S1 is there, S2 is there, S2 is there, S4 is there, S5 is there, S6 is there. That means there exists at least one real number such that all the sequence terms are right side to that real number. That's what bounded below sequence. Suppose you take this sequence. This n is equals to, like we can take 1 over n, or else you can take simplest example, n, simply n, then you understand. What is this? 1, 2, 3, like this. Therefore, what you get? 1, 2, 3, 4, 5, 6 going on. So I'm going to choose a natural real number k. What is my k here? My k is 1. I can take k equals to 1. This, if I choose k equals to 1, each term always bigger than or equals to that 1. Each term of the sequence always bigger than or equals to 1. Therefore, this is bounded below sequence. What is this? This is bounded below sequence. Because 1, I can find a k such that each term of the sequence is right side to that k. So kn is bounded below sequence. Suppose you take this minus n such that n belongs to n. This is -1, this is -2, -3, -4. Can you find a real number such that all the terms are left sides here? No. Can you find a real number? Can you find a real number? No, right? Can you find a real number? All the terms are sequence terms are right side to k. Is it possible? Is it possible? You take any real number, definitely what you get? I can definitely find a real number. I can find a sequence term which is bigger than this k is bigger than minus n. Suppose మీరు ఇక్కడ ఇచ్చారు అనుకోండి k dash k1. I can choose the sequence term which is less than or equals to k1. Therefore, it's not my bounded below sequence. It's not my bounded below sequence. Bounded below sequence, because you give me what is meant by bounded. Bounded below, we find a real number. There is no such a real number in such a way that this is true. Bounded below sequence. You can prove by Archimedean property easily. Bounded below sequence. You can take it as an exercise using Archimedean property, right? Because no term is, see, does there a term which is ended? No, because it is continuing. మీరు ఇక్కడికి ఇస్తే నేను ఇక్కడ ఇస్తా sequence term. మీరు ఇక్కడ ఇస్తే నేను ఇక్కడ ఇస్తా. It is not ending. It kept going on. -1, -2, -3, -4, -5, -6. It is keep going on, keep going on. There is never ending process, right? So therefore, it's not bounded below. Suppose you take this. Is it bounded below? Yes, because it is ending process. There is an ending process. We have seen 1, 2, 1/3, 0. So I can choose k equals to 0. In fact, 0 is always less than 1/n for every n. Therefore, all the sequence terms which are right side to 0. Therefore, Sn is bounded below. Suppose bounded above. Or else you can take another example. You understand. Let's suppose you take this. What is my first term? 2. Second term is, what is second term? 2 plus 1 by 3/2. Third term is 4/3. Like this, going on, tends to 1. Therefore, what you observe? I can choose k equals to 1. So each term is bigger than 1. Therefore, Sn is bounded below. Sn is bounded below. Fifth one. Suppose Sn is equals to -1 whole power n by n, as that n belongs to n. What is my first term? -1 here. What is my second term? 1/2. What is my third term? -1/3. What is my fourth term? 1/4. What is my fifth term? -1/4. What is my sixth term? 1/6. So therefore, all the terms, what you observe? Lying between -1 to +1/2. I don't require this right now. What I'm interested? Lower bound. Therefore, 0 for every n. So what is my k? I can choose k equals to -1. Of course, you can choose k equals to -2 also. -2 also lower bound for the sequence. This one. So this is bounded below. Right? So next is bounded above. So bounded above sequence means you take a sequence of real numbers is said to be bounded below bounded above, sorry. If and only if we find a real number such that sequence terms are left side to that k. Find a real number on the number line. All the sequence terms are left sides. Of course, they can be interchanged here, somewhere. I don't require the order of the sequence, but what you observe is all the terms are left side to that k. We need to find such a k. If there is no such a k, it is unbounded above sequence. If there is no such a k, that means there is no k in such a way that all the terms are left side to k, it's unbounded above sequence. Example, you can take example. Suppose you take this n square or n cube, you can take anything. What is this? What is my first term? 1, 2 square, 4, 3 square, 9, 16, like this. That means what you observe is this 1, 2, see 1, 4, 9. What is the second term? 4, 9, 16, like this. So what you observe is it upper bound of the sequence? Is it a bounded above sequence? No, because you give me k, by accompanying property I can choose n. If k is then n, I can choose n square bigger than a. So therefore it is not bounded above sequence. మీరు ఇక్కడ ఇస్తే k, నేను ఇక్కడ choose చేస్తా. మీరు ఇక్కడ ఇస్తే k, నేను ఇక్కడ choose చేస్తా. So this is never ending process. So therefore not bounded above sequence. Of course it is bounded below. Of course it is bounded below because each term is right side to 1. Of course it is bounded below. Suppose you take this 1 by root n such that n belongs to n. So what is my first term? 1. Second term is 1 by root 2. Third term is 1 by root 3. 1 by root 4. Like this going on. So what you observe is on the number line. This is my 1. 1 by root 2 is left side to this. 1 by root 3 is left side to again 1 by root 2. Going on towards 0. So what you observe is 1. I can choose k equals to 1 here. Therefore each term is left side to k. Left side to 1. Therefore what you observe? This S is bounded above sequence. Is it bounded below? Yes, because I can choose k equals to 0. Of course it is bounded below also. Right. Next is third one. Suppose root n such that n belongs to n. Is it bounded below? Bounded above? Look at number line. This is 1. This is root 2. This is root 2. This is root 3. This is root 4. Like this. So clearly it is bounded below because 1 is left side to each number of the sequence. This is true for every n. Is bounded below. Is bounded below. But it cannot be bounded over because మీరు ఇక్కడ ఇచ్చారు అనుకోకే నేను ఇక్కడ చూస్ చేస్తాను బై ఆర్కిమెడియన్ ప్రాపర్టీ. మీరు ఇక్కడ ఇస్తే కే నేను ఇక్కడ చూస్ చేస్తాను. సో ఇట్స్ నెవర్ ఎండింగ్ ప్రాసెస్. సో దర్ఫోర్ ఇట్ ఇస్ అన్బౌండెడ్ బిలో, అన్బౌండెడ్ అబౌవ్. Okay, so this is bounded above, bounded below. Next is bounded sequence. The sequence is bounded. The sequence of real numbers is bounded if and only if it is both bounded above and bounded below. That means we find some real numbers, no need to positive, such that it has a lower bound It has an upper bound for the sequence. That means all the terms which are bounded below by K1, bounded above by K2. Therefore, this range of a sequence, that means what? It should be, the sequence term should be contained in this. That means range of a sequence should be contained in K1 and K2. And that means this range of a sequence is set. You know, this is a bounded set. Why it is bounded set? Anybody? Because K1 is a lower bound, K2 is an upper bound. We have seen subset of bounded is bounded. Therefore, range of a sequence is bounded. So that means a sequence is bounded if and only if the range is bounded. This is actually Rodin definition. So a sequence is bounded if and only if it is the range is bounded. Sequence is nothing but after all a function. After all a function. When do you say that a function is bounded? We have seen its range is bounded. We have seen its range is bounded. Sequence is after all a sequence function. Therefore, the range must be bounded. Right? So look at example. Otherwise, it is unbounded sequence. You need to write it. Otherwise, it is called unbounded sequence. Means not bounded above sequence, not bounded sequence. Okay. Suppose I'm going to take this. Is it bounded sequence? Yes, because what is my range of a sequence? My range of a sequence is, see, there are two ways. See, what is my definition? There are so many definitions. You need to provide a lower bound. You need to provide a lower bound. You need to provide an upper bound. Or else you need to show that a range is bounded. This is one definition. This is one definition. Both are same equivalent. We have shown. But the thing is, you need to provide lower bound. You need to provide upper bound. Yes or no? Therefore, simplest way is you need to find it is bounded below by bounded above by 1. This is my 1, this is my 1 by 2, this is my 1 by 3. Therefore, what you observe? 0 is a lower bound, 1 is a upper bound. Therefore, it has a lower bound as well as upper bound. Therefore, Sn is bounded sequence. Sn is equals to, suppose, 1, 5, 1, 6, 1, 7, 1, 8, like this. So what you observe is, first term is 1. First term is 1. Second term is 5. Third term is 1. First term is 1. Second term is 5. Third term is again 1. Fourth term is 6. Again, fifth term is again 1. Seventh term is actually what? Not 7 sum. Sixth term is what? 7. Like that. So what you observe is, you're going to get like this. That means lower bound of a sequence is 1, but there is no upper bound. Therefore, it is bounded below. But not bounded above. So therefore, Sn is not bounded sequence. Because see, what is meant by bounded? It should be both bounded above as well as bounded below. At least one of the condition fails means what? It is unbounded sequence. That means it's not bounded above, not bounded sequence. Right? So this is what about a boundedness. Of course, you can give a lot of examples. You can provide. Not example, I think. Sn is equals to, suppose, 2 plus 1 by n such that n belongs to n. Is it bounded? Yes. If you take n equals to 1, 3, n equals to 2 means 5 by 2 left side to this, and n equals 3 means 7 by 3 going on 2. Therefore lower bound is 2, upper bound is 1. Therefore it is bounded sequence. Right? Suppose you take this, Sn is equals to 1 plus 1 by factorial 1, 1 by factorial 2, 1 by factorial 3, 1 by factorial n. Yeah, tell me your option, answer in the chat box. Is it bounded? This is my sequence. Tell me your option in a chat box. Yeah. Shiprasad responded, and bounded was also responded. So this one I'm also responded. Krishna also responded. Jyoti also responded. Monica also responded, and Srinivas responded. Shiprasad also responded. Yeah, Shivakumar also responded. See, if you want to say that it is bounded above, bounded below, first you need to know that. First you need to mention what is the lower bound, what is an upper bound. Anybody? Give a option. Respond in chat box. What is the lower bound? If it is bounded, what is the lower bound? If it is bounded above, what is the upper bound? Anybody? Yeah. Okay, responded. Most of them responded. Okay, we'll see. What is the first term? First term is 1 plus factorial 1. What is my first term? My first term is 1 plus 1 factorial. What is my second term? 1 plus 1 factorial, like this. Third term, like this. This is my sequence. Question is, this is very standard problem. So this Sn is nothing but 1 plus 1 factorial is 1, 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3, 4 factorial means 1 into 2 into 3 into 4, n factorial means 1 into 2 into 3 into up to n. So n factorial, go through this standard inequality. N factorial is always bigger than 2 power, what is n factorial? 2 power n minus 1 for every n bigger than equals to 3. Right? Suppose you take n equals to 3. Here, what is this? This is 6. This is what actually? 2 power 3 minus 1 means for 4. When you take n equals to 4, 4 factorial is 24. This is 8. Whenever n equals to 4, you are going to get 24, here 8. Whenever n equals to 5, 5 factorial, I think, what is 5 factorial? 24 5 is 120. This is 2 power 4. 2 power 4 is nothing but 16. Therefore, this inequality is always true. This is a very famous inequality. Keep in mind when I will go through the series. Keep in mind. So therefore, this is 1 factorial. So that means 1 by n factorial is always less than 1 by 2 power n minus 1. This is 2 power n bigger than equals to 3. Right? So this is always true. Therefore, this is 1 plus 1 factorial. So 1 by 2 factorial means 1 by 2. 1 by, this is 3 factorial. 3 factorial means what? 1 by 3 factorial always less than 1 by 2 power 3 minus 1 means 2 square. 4 factorial means 3. N factorial means 2 power n minus 1. So this is 1 plus 1 by 2 like that going on. That means what? This is exactly 1. You need to mention 1. Therefore, this is just, you keep this. This is a sum. In fact, this is in geometric series. What is the common ratio? 1 by 2. Therefore, this series is convergent series. This is meaningful series because my common ratio is 1 by 2 less than 1. Therefore, this finite sum is less than series because this series is meaningful series. Therefore, this is 1 plus, what is this? This is geometric progression series. So common ratio is less than 1, a by 1 minus r. Therefore, 1 plus, what is this? This is 1 by 2. Therefore, 1 plus 2, that means 3. Therefore, what you observe? Sn is bounded above by 3 for every n. What is my bound first term? First term is actually what? Bounded below by, what is my first term? 2. In fact, it's an increasing sequence. We'll see later. So, first, what is my first term? First term is what? 2. 1 plus 1 is 2. 1 plus 1 plus 1 factorial, 1 by 2 factorial. This is an increasing sequence because terms are increased. Because non-negative terms always increasing, we'll see later. Therefore, Sn is bounded sequence because it is bounded above as well as bounded below. Right? Of course, it is converges to E. Right? This is very important question. Suppose you take this example number 5. Sn is equals to 1 plus 1 by 3, 1 by square, 1 by 3 cube, 1 by 3 power n. Tell me your opinion in the chat box, whether it is bounded or not. Tell me opinion in a chat box. If it is bounded, you need to mention the lower bound. If it is bounded below, you need to mention the lower bound. Your chat box. Yeah, most of them responded bounded, lower bound 1. Most of them responded. So this Venom also responded. Good. 2.5 and 1. I don't know 2.5 or not. Yeah, responded. Good. So this is also standard question again. It's a series actually. We have seen the last problem technique. We are going to apply the last problem technique. So what is my sequence term? 1 plus 3. When you take n equals to 1, 1 plus 1 by 3. This is my first term. Whenever n equals to 2, 1 plus 3, 1 by 3 plus 1 by 3 square. This is my second term, like that going on. So clearly we observe that it is increasing sequence. Increasing sequence, this is a lower bound because increasing sequence is bounded below by this term. That means what? 4 by 3. So this is bounded below clearly. I don't know whether it is bounded above or not. So it is bounded below by 4 by 3. Okay, this is clear. Question is it bounded above? Look at the first terms. 1 by 3, 1 by 3 square. Again going on 1 by 3 power n. Therefore, already told you this is a series. This is a nth partial sum of this series. Nth partial sum of this series. This series is convergent series by geometric series. This common ratio is 1 by 3 because 1 by 3 by 1 is 1. 1 by 3 square by 1 by 3 is 1 by 3. This is less than 1. This is a convergent series. This series is convergent. Which series is convergent? This series is convergent by geometric series. So once if the series is convergent, this series is a meaningful series. So what is its value? A by 1 minus r because it's a geometric series whose common ratio is less than 1. That means what? This is 1 by 2 by 3. That means what? This is 3 by 2. Therefore, bounded below by 4 by 3, bounded above by 3 by 2. This is therefore n belongs to n. So therefore, S is bounded below as well as bounded above. Therefore, Sn is bounded sequence. That's it. right? So this is a very important result, right? Very, very important. Boundedness is very, very important. Without boundedness, there is no convergent, because if every convergent sequence is bounded, if it fails to be bounded, it is not, it's convergency. So we'll see later. Next is limit point of a sequence. Right? A sequence, you consider a sequence of real numbers. So a real number P, you take a P, real number, which is a P is a real number, said to be limit point we have seen limit point of a set. Yesterday, before yesterday, limit point of a set. Kada? Put limit point of a sequence. If one only, you every neighborhood of P contains infinitely many terms of the sequence. That's it. Infinitely many terms of the sequence. That is same as saying that every neighborhood you take contains is an infinite set. Simply say that is contains infinitely many terms. Terms of Sn. That's it. Every neighborhood that you take, this is true for every neighborhood. So example, you take Sn is equals to simplest example, minus 1 whole power n. What is my sequence? Minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1. So what are the limit points of the sequence? Minus 1, 1. Right? Suppose you take this real number. You take this real number. Is it a limit point of a sequence? No. You take some neighborhood, in fact less than 1. You take very small neighborhood. Does it contain any terms of the sequence? Does it contain any terms of the sequence? No. What is my definition? Any neighborhood contains infinitely many terms of the sequence. Does it contain any terms of the sequence? No. Therefore, it cannot be limit point of a sequence. Is it a limit point of a sequence? No, because I provide some neighborhood which never contain a single term, in fact, of the sequence. But what I require to define a limit point? It contains infinitely many terms. Every neighborhood that you take, it contains infinitely many terms of the sequence. So unfortunately, fails to have infinitely many terms. In fact, fails to have at least single point in the red region, pink region. So it cannot be limit point. Suppose you take this, you take any neighborhood, minus 1 minus epsilon plus minus 1 plus epsilon. It contains so many odd terms, infinitely many odd terms. It contains all odd terms, in fact. It contains this region. In this region, all S1, S3, S5, S7, S9, S11, S13. It contains all terms, all odd terms. That means this neighborhood contains infinitely many odd terms of the sequence. Therefore, minus 1 is a limit point of a sequence. Right? Similarly, is it a limit point of sequence? The answer no, because I provide some neighborhood which fails to have at least one point. At least one point. But what I require infinitely many points. So therefore, this cannot be a limit point of a sequence. Is it a limit point? Yes, because you give me any neighborhood, any small or big neighborhood, it contains all even terms, because even terms are nothing but 2, 4, 1. So all 1, 1, 1, 1, 1, 1, all ones are there, all ones, because S2, S4, this contains S2, This neighborhood contains S2, S4, S6, S8, S10 going on all even terms. Therefore, every neighborhood of 1 contains all even terms of the sequence. How many even terms? Infinitely many, countably infinite. Because S2, S4, S6 is a sequence. So therefore, automatically it's just countable. So therefore, 1 also limit point of a sequence. Yeah, question is it a limit point of sequence? The answer no, because I provide a very small neighborhood which contains no limit point of sequence. Therefore, it's not a limit point of a sequence. So is it clear? Just respond in chat box. Is it clear, Annie? Just respond in chat box. Yeah. Okay. So with this, I conclude. By tomorrow, I'm going to start the difference between limit point of a set and limit point of a sequence and properties of limit point of a sequence. With this, I conclude the lecture. By tomorrow, I'm going to start properties of a limit point of a sequence and the difference between limit of a set and limit point of a sequence and limit of a sequence, of course. We'll see by next tomorrow. It means Monday. Yeah, any doubts, respond. But again, my doubts. Feel free to ask doubts. Sirisha. Example number 4. Which is example number 4? Oh, this one. So this is a very standard inequality. N factorial is bigger than 2.